Right, hello Year 8. So today what we're going to do is actually, I'm going to set you a little task, and it's actually a practical that I'm hoping that you can do at home, okay? Um, if you have trouble doing this right away, then what I suggest you do is copy down the method during the lesson time now, and possibly have a go at doing the actual practical side of this maybe later or even on another day if you can't get to a certain spot which is specific. But I'll explain what I mean in just a moment. Right, now the first thing we need to do is go through the answers to the questions from last lesson. So there was the questions which were on the sheet. So here come the answers for that. I'll quickly talk you through them. But these will also be, this sheet will also be an assignment because I'm going to go through this quite quickly. So don't worry if you can't 100% keep up right now. You can always check them on assignment in a moment. So the first one, waves transfer energy without transferring matter. In a transverse wave, movement occurs at right angles, or you could have said perpendicular to the direction of wave movement. In a longitudinal wave, the movement occurs parallel to the direction of wave movement. Next thing you had to do was draw on the diagrams. So for a transverse wave, the movement was up and down, so you should have had an arrow indicating up and down. It doesn't need to be there, it could be anywhere as long as you've done it. And then you should have had, for a longitudinal wave, the movement going backwards and forwards. And you label a compression where particles bunch up and a rarefaction where they spread out. Type of wave is transverse. For this one, it's longitudinal. And examples would be water waves, light waves, and some kind of earthquake waves. An example of longitudinal is sound and earthquakes. So again, it was asked to complete the sentences below. So areas of compression and rarefaction are features of longitudinal waves. In an area of compression, particles are pushed closer together, or something along those lines. Compressed, I would accept. In an area of rarefaction, particles bounce apart again or separate. Right, then you needed to label this part, this diagram of the wave. So this one was equilibrium line. I also would have accepted a number, 0. That is the wavelength, the amplitude, the peak or crest, and that is the trough. And then it asked for some definitions. So top of the wave is known as the peak or the crest. The bottom of the wave is known as the trough. Equilibrium line, that is the level if the wave flattened out. Oscillation, a repeated action back and forth or up and down. Frequency is the number of waves that pass every second, and it's measured in hertz. A period, the time it takes for one complete wave to pass, is measured in seconds. The wavelength, the distance along one full wave cycle measured in meters, and the amplitude, the height of the wave above the equilibrium line. Okay, so there are your answers, and I'll also put those up on assignments. So if you didn't quite get them all, you can go back in later and just check. Okay, so the first thing we need to do today is I would like you to write down the title. We're going to investigating wave speed, and here there are, oops, how many? I think 8. No, 9. Okay, I'll show you the first 7 and I'll go down to the other 2 in a moment. I would like you to write down these statements and whether or not you think they are true or false, and then just one sentence to say why. Okay, and then we'll go through that in a moment and I'll also reveal the other 2. Okay, so pause the video and write these down. And then next to them, are they true or false? So simply true or false. And then underneath, you can just simply write your reason why. Okay, and then I'll show you the other 2 in a moment. So pause the video and do that now, please. And here are the other 2. Here are 8 and 9. So once again, pause the video, answer 8 and 9, and see how you got on. Okay, so here come the answers. Water waves are transverse. That is true. Water waves oscillate up and down. Would be your reason. Sound waves are not transverse waves. That is true. They are longitudinal waves. Sound waves travel as longitudinal waves would be your answer. The oscillation of a longitudinal wave is at right angles to the direction of energy transfer. That is false. Okay. Transverse waves are at right angles. Longitudinal waves are parallel to the direction of energy transfer. So that would be your reason to put in. All waves transfer energy and not matter. That is true. Okay, so you could say simply, no matter is transferred from one place to another, but energy is. That'd be your reason. Frequency is the distance from one peak to the next peak. That would be false, because wavelength is the distance from one peak to the next. Frequency is measured in joules. That is false. Frequency is measured in hertz. Energy is measured in joules. Let's move this down. Right. Earthquakes are caused by transverse and longitudinal wave. That is true. Earthquakes basically give off several kinds of waves, and there are a type which are transverse and there are a type which are longitudinal. You'll learn as you hit GCSEs that transverse waves are called primary waves and longitudinal waves are secondary waves. So that again, that could be your reason. 8, if frequency increases, wavelength decreases. That is true. As you get more and more waves, what happens is the waves tend to get bunched up, which means the wavelength gets smaller and smaller. Okay, so that's true. Although I'm going to put a caveat to that. Generally, there is an exception, and again, you won't know that until year 11, but just for now, you can put that. And then 9, final one, the amplitude is the height of the wave from its point of rest. That is true, okay, because the amplitude is the height away from equilibrium, and that again would be your reason. Okay, so you should have had true or false, and again, a very simple reason as to why they were true or false. So again, if you need to quickly go back and listen to my answers, feel free to do that and just copy those up. So today, what we're going to do is I'm going to set you about a task to calculate the speed of, well, in this case, a sound wave, not a water wave. Hopefully try and get accurate results, although I understand without certain measuring equipment, it might be difficult. And then we'll try and answer some exam style questions if we have time at the end. So the first thing I'd like to do is copy this into your book. Now, some of you might be familiar with this, okay, and come across this before. This is how we calculate the speed of a wave. Okay, so let's just see what we need to know. What do we need to know about speed? Well, we need to know how far an object has gone. So D stands for, to make that a little smaller so you can type it in, distance. Okay, D is distance. Okay, and you think, what do we measure distance in? Well, of course, we measure it in standard unit meters. Right, the next one, what is T? T is, of course, time. Our standard unit for time is seconds. So, distance divided by time equals speed. And speed, just quickly type that in, is measured in meters per second. Okay? So, link here is very simple. Distance divided by time will give you the speed of the wave. So if you know how far it's gone and you know how long it took, you can work out how quickly that wave is traveling, the wave speed. Okay? However, sometimes they might ask you something. This is how the three are linked. Distance divided by time gives you speed. What if they decided to give you the speed and the time? How would you work out the distance? Right. Well, to do that, what you would do is speed times time equals the distance. And then, what if they gave you the distance and the speed? well, then they'd be asking you to work out the time, how long it took for that wave to travel. So to do that sum, it's distance divided by speed equals time. So you can see how the three are linked. Now you will have come across triangles like this before, I hope. But if you haven't, this is a really useful way to work this out. Okay, so speed, distance, time. Speed, distance, time triangle. This will probably crop up again in year 9 and also in year 10 and 11. It's very common, okay, to work out speed. All right, so pause the video and make sure you've got that in your book. So remember, distance divided by time equals speed. Distance divided by speed will give you the time, how long it took, and speed multiplied by the time will give you the distance, how far the wave travelled. Okay, so pause the video and do that now, please. Okay, so this is the practical that I'm going to have you do. You're going to essentially work out how fast sound wave travels through air by this very simple method. So what you're going to do is clap, and you're going to stand a set distance from a wall. I suspect your 50 meters is probably too far to a distance to travel, so we won't use that. All you will need is a tape measure and a stopwatch, maybe on your phone. Okay, so what you'll do is go and find yourself a wall, and I appreciate you might need to do this away from your home because it might annoy the neighbours, but if you've got a decent wall which you could stand perhaps 10 meters back from, okay, 50 is a little far, okay, and if you've got something that can make a nice big bang, like 2 blocks of wood, but you can probably get away with using your hands, it might work. So stand some distance away from a large wall. It's got to be a nice, firm, solid surface like a wall, and clap your hands or your blocks of wood together. Again, please don't do this if it's going to annoy your neighbours. Find somewhere more discreet to do it. You should hear an echo. Now clap the blocks at a steady rate so that a clap occurs at the same time the echo reaches you. Now there's going to be an element of judgment in that, okay? So you'll have to try and listen quite carefully. You might need to employ an assistant for that part. Then, using a stopwatch, time 20 claps. Then you divide this time by 20, and that is the time it takes for the sound to go from you to the wall and back again. So the sound will travel from your hands, hit the wall, and bounce back to your ears. And that's hopefully, well, if it was say 10 meters there, 10 meters back, so 20 meters. What you then do is measure the distance from the wall. Okay, so if you've pre-measured it, that's fine. And then you calculate the speed of the sound, because hopefully you'll know your distance. So again, if you're standing 10 meters back from the wall, 10 meters there, 10 meters back, that's 20 meters. So that's your distance. That's how far the sound traveled. You time how long it took to do 20 claps, and then you divide that number by 20, and that will hopefully give you a fairly accurate answer. So what you can do is firstly pause the video at this point and copy down the method, and you can include this little equation because it's slightly different. So distance divided by time equals speed, but it's twice the distance because remember it's there and back again. Okay, so pause the video and copy up this method. So what you will then do is you can have a copy of this table in your book like this. Okay, so let me explain exactly what this is. So you might want to pre-write this in before you go out and actually do this. So what you do is you do your 20 claps standing back from your wall, and you time how long it takes. And then you do the same thing again and the same thing again. And the reason we do it the same experiment 3 times is because the first time you might be a little out, or the second time you might be a little out. So your third time you do it is an amalgamation of your answers. So say for example, let's just say it took, I don't know, 35, these are just average guess, 35 seconds to do 20 claps. The next one, it took 37 seconds, and the next one maybe 36 seconds. Okay, now what we do is we would work out the average time for this. Okay, so it's actually very, very straightforward. What you do is you simply get your calculator and you do 35 add 37 add 36 equals 108. However, you did it 3 times, so you divide it by 3, and your average would be 36. Okay, so you could do 20 claps an average in 36 seconds. So therefore, how long did it take you to do one clap? Well, that's quite simple. You take your 36 and divide it by 20. The time for one clap was 1.8 seconds. So I can't draw with a pen like this on the screen. So 1.8 seconds. Now, we know maybe that our distance to the wall was 10 meters. Okay, so we can put that in. And then to work out the speed of sound, what we would do is 2 times the distance to the wall. Remember, it was there and back again. So what I would do is I'd take my calculator and I'd go, right, well, 2 times 10, well, that's easy, that's 20, divided by the time for an echo, which was 1.8, and according to this, that would come out as 11.1. Okay, I'm going to tell you right now, that's wrong. That's way off. That is nowhere near the speed of sound. Okay, but hopefully that serves as an example of how you could do this. Okay, I'll give you a hint. The number should be significantly higher than 11 meters per second. Okay, but I'll leave you to see if you can figure out what it is. Okay, so essentially you're off doing your practical today. If you can't do it right away, what I'm going to do is I'm going to upload some questions for you into the assignment, and you can do that now, and then you can have a go at the practical at your convenience. Okay, and I will check that with you when I next see you, which will be next week. Okay, so I'll leave the assignment open so you can still upload your experimental data a bit later. Okay, if you have any real problems going off and doing the practical, do let me know. You don't necessarily have to do it right away. All you need is seriously a tape measure or some way of measuring a distance, and a stopwatch, which you probably have on your phone. Okay, distance, I suppose I would accept rough estimates. So a meter is like, for you guys, one big stride. So if you did 10 big strides against a wall, away from a wall, that would be about 10 meters if you have trouble finding a tape measure. Okay, but use your initiative. It's designed to give you an approximate idea. Okay, right, so good luck, and I'll be online to help you out if you need.